developer-centric view onto HTML5. You know, I assume that you have seen some of those demos, that you have seen, I don't know, for a beautifulweb.com or things like these, where browser manufacturers like Microsoft show off the features of their HTML browsers. Usually these demos today are targeted towards graphics, effects, etc. Now, I'd like to take some kind of a different approach. I'm going to view or to show you HTML5 from a developer's point of view. No matter if you develop desktop applications today or Silverlight applications or web applications, what you're going to see in the next in this session is something which I think will be important for you. I personally think that we are seeing a big change coming, and within the next 75 or 74 minutes now, you're going to see why I believe that we have this big change and what you as a developer can do to take advantage of this. As always, there will be a lot of samples. You will be able to download them from our weblog. That's the address on the bottom, weblogs.thinktexture.com/Ingo. If you've got any questions afterwards, please don't hesitate to come to me, ask them. I'll have a lot of time for you. I'm here throughout the day. If there are any questions later on, feel free to send me an email to ingo.rama@thinktexture.com. Okay, what's this session about? Well, when talking about HTML5, I could talk about what's coming, about things which might be there when the standard gets to a reasonably finalized way in 2015 or 14. Now, that's not going to help us very much. So what I'm going to show you instead is things you can do today on today's browsers. I'm going to show you how to do fallbacks or how you can take advantage of frameworks which allow you to fall back. A number of the things I'm showing actually come with fallback solutions which work down to IE6. Well, nobody wants to run IE6 anymore. Microsoft's putting a lot of effort in, of course. But still, that's the interesting thing. When people look at HTML5, one of the points of view could be to say, well, you know, that's not for me because my customers don't run HTML5 browsers and they won't update, you know, within the next 2 years. But on the other hand, there's a way to view HTML5 which is called progressive enhancement, where you can create sites which just, you know, offer more features to your users if they have an HTML5 browser, but which still continue to work perfectly if they have an older downstream browser. So I'm talking a lot about what's available today, and I'm talking a little bit about the vision. In fact, I will spend about 5 to 10 minutes at the beginning showing you a few slides about some of the ideas behind HTML5 and why this is important for you, even if you don't create web pages today, and then we'll go into the code. One thing which is important is I do not work for Microsoft. Actually, the interesting thing is nobody from Microsoft has ever seen this slide deck before. I could show you Chrome, Safari, etc. Nobody has reviewed my content. Everything I'm saying here is my own opinion. That's important because I will present some statements which are forward-looking. The way I think the world will change in the next year or so, but these are not Microsoft statements. These are just my opinion, just my current thoughts of application platforms. What Microsoft does say is the following, and that's interesting. I'll give you just a few seconds to read this and to digest this. We believe that HTML5, etc., will allow you to create applications which are just as vivid, interactive, and high fidelity as what you've come to expect today from native applications. That's an interesting statement. That's a statement by Microsoft. But let's just think about this. HTML5, as Microsoft sees it, will be a platform which allows you to create apps which perform, which interact with the user, etc., like local applications do today. That's a quite powerful statement. The statement would not be as powerful if Microsoft would be the only one saying something like this. But it's extremely powerful because it's not just Microsoft saying this. It's Microsoft, it's Apple, it's Google, and it's RIM, whether or not they might be important in the next decade or so, is on a totally different page. But the important thing here is what you're seeing here is currently the largest part of market share in desktop and in the mobile space in total, including tablets, mobile phones, all kinds of laptops, notebooks, etc. So we are looking at something where all the vendors stand behind and say, you know what, we believe in this. All the vendors have registered nice HTML5 websites. Apart from RIM, they have a longer URL somewhere on their site. Now, the next thing is, what you're seeing here is currently the largest part of market share in desktop and in the mobile space in total, including tablets, mobile phones, all kinds of laptops, notebooks, etc. So we are looking at something where all the vendors stand behind and say, you know what, we believe in this. All the vendors have nice registered HTML5 websites. Apart from RIM, they have a longer URL somewhere on their site. Well, what is this HTML5 thing? And when we talk about HTML5 from a technical point of view, we usually talk about the combination of HTML5, CSS3, and JavaScript, modern JavaScript. I'm going to come back to this quite a bit throughout this session. Together, these provide a common application platform for all kinds of devices. These applications run on all kinds of operating systems, including all currently known mobile operating systems, apart from, well, unfortunately, Windows Phone 7 today. There will be the fall update, which will provide you with an HTML5 browser on the phone. And at this point in time, as soon as you have this update, HTML5 is your lingua franca for all kinds of devices. It's the only thing for which you can use to create pages, applications for all kinds of devices. Is this a write once, run everywhere situation? Well, you know, this slogan is not really a Microsoft slogan. Some of you who've been around for a while might remember this. So today, the question is it rather a write once, debug everywhere application? And I can tell you, I've been writing HTML5 apps for mobile devices for quite a few months now, and I test them on a number of devices. And yeah, you have to test them on every device today. You know, there are differences between the browsers, no questions. That's a real photo. That's not Photoshop. That's how the devices look like. It was extremely hard to get them to be turned on at the same time because they shut down after about 15 to 30 seconds. So it's really like, try it again. No, damn. And you can see I have not managed to actually turn all of them on at the same time. But you know, all these devices, apart from the Windows Phone, which we'll get it later on, run HTML5. Now, when I say run HTML5, a lot of people might think that I'm talking about web applications. But I tell you what, web applications are just the first step. But let's take one step back. I've been creating web applications for 17 years now. I started in Perl, running on Linux, running on Apache 1.12, I think. IE1 was not available at that time. There was Mosaic was our browser at that time. This makes me feel a bit old now. This makes me feel a bit older than I actually am. But I've been around for way too long. So however, what did we do for all these times? First we did the old school web. And I'm only talking about dynamic web. I'm not talking about static web. Old school web, you have a browser, you have a server, you have a framework, maybe ASP.NET Web Forms, maybe MVC. You issue a request, your framework runs, goes to the database, reads data, returns HTML, dynamically generated HTML. No matter if you run this on ASP or on Ruby or on whatever Java servlet platform, that's what happened. And if your user later interacted with the application, let's say your user clicked the button, you would have another round trip to the server. Server will go through ASP.NET to the database, return a new set of dynamically generated HTML. This world stopped about 5 years ago, more or less. For some people, it stopped earlier. For some people are still doing this today. For some applications, it's perfectly okay. Now, and then, of course, Ajax came along. In Ajax, the first part is pretty much the same. You get dynamically generated HTML from your application framework. But when the user interacted with the application, we didn't really send a full request for a new page. Instead, we ran JavaScript on the client side, issued an HTTP GET using XML web requests or whatever, maybe going through WCF to only send data back to our web application. This was the main difference. So we have data, and we use JavaScript to render data. Okay, everybody, we know this. So the next step is offlineable data. Up to here, it looks exactly the same. So if you look at our random HTML5 application, and that's now HTML5, that's a new feature, it looks the same up to a certain point. Well, the first difference is, quite on the top, you could now get served static HTML. The HTML doesn't even have to be dynamic, it could be static. All the samples I'm going to show you later today are purely static HTML files. All the dynamic parts are purely based on the client. But the important thing is, after retrieving your data, after sending data to your browser, the browser can now store it in its local store. So that's the main difference. Locality. HTML5, now that's just an example, but HTML5 means locality. You can create applications which run things locally, both for data and for your code. And you then run JavaScript to display data. But if you would now interact with the data, you could interact with your local cache. This could be persistent. So it's not just in memory, but this could be cached on the user's disk. If the user restarts your application, you can immediately present them with data, with meaningful data from a previous session, etc. And in the future, and that's now the personal opinion, what I think, what we've looked at, what we've viewed in the past few months, we see a certain way how applications might evolve. You'll have your browser, and your browser might not even make a connection to a web server. Your browser, your HTML rendering engine, goes to a locally stored HTML5 application and uses the browser. Well, the user interacts with the browser with your shell, runs JavaScript, interacts with a local storage. So that's the same thing. We're now talking about a local application interacting with local storage. That's not a web page anymore. We are talking about applications now. And of course, they can interact with a server at some point in time, but they will just sync up using HTTP gets and posts, etc. Just like your Silverlight out of browser application. These are things I envision for the future. Now, today, for some other browsers, there is a standard which allows this today, which is implemented on Chrome, Firefox, and Safari, but not yet on the Microsoft side. I think that Microsoft will implement this. There are a few issues with this standard and about cache control, about how to update applications, which have not been fully solved so far. But as soon as you look into this, we are far from the web page of today or even of yesterday. So again, the reason for this session is that HTML5 presents you not just with another thing to create web pages, but with an application framework which allows you to run apps on all kinds of devices which are available today. On nearly every platform, there's an HTML5 browser. So when will it be done? That's the important question for most developers. And the thing is, that's not the right question. The right question actually is, when will it be ready? Because it won't be done. HTML5 has been declared a living standard. There will always be iterations. But in HTML5, there are always ways to live with this fact that there are iterations. And so what remains? We have HTML5, we have CSS, and we have JavaScript. And the thing is, when I speak to developers who have lived the last 12 years or 10 years in .NET space, a lot of them don't, well, let's put it nicely, they don't like JavaScript that much. Well, some of them hate it fervorously. Okay. Now, I love JavaScript. It's a fantastic language. It does things which, when I go to C#, when I switch between those, there are always things which I'd like to see in C# coming from JavaScript. Of course, also the other way around. Now, if you today think that JavaScript sucks, you might have simply missed the best parts of JavaScript. And I did. I've done JavaScript programming since JavaScript came out in the first browser, and I can't even remember when this was. If you've missed the best part, there is a book which is called JavaScript, The Good Parts. Yes, there are good parts. And this book is by Douglas Crockford, the guy who has invented JSON, the JSON notation, and it's a fantastic book. It's JavaScript, The Good Parts. If you don't want to shell out money for this book, you can just look for Douglas Crockford's website, and a lot of his articles and of his thinking around JavaScript are available for free as well. But be aware, this book will change everything you think about JavaScript today. When we're talking about JavaScript, about object orientation, about how to modularize things, about how to create private methods, private functions, etc., which are not directly obvious if you just look at JavaScript, the language, how it's used today, then this book will change your opinions. Okay. While we're at it, while we're looking at books, there's another one which will be interesting for you that's called HTML5 Up and Running. That's also available for free. And the same content is available for free at diveintohtml5.com. These two books together would be the perfect starting point if you're interested in the HTML5 future. So the next question is, well, so we can now accept that, there are good parts in JavaScript, but we're still not very happy. Is this slow? JavaScript used to be very, very slow. And the thing is, that's a pretty new benchmark. And the shorter the bar is, the better the performance is. And IE8, was the first one on the left. Now, IE8 was, to put it nicely, not known as a very fast browser for JavaScript. If you look at IE9 now, we are, I don't know, more than 10 times faster in terms of JavaScript performance. You're going to see some JavaScript later on which animates hundreds of objects on the screen and gives us 60 frames per second. And so no problem about the JavaScript performance. IE9 pre-compiles JavaScript. But even the other browsers are pretty good in performance. IE9 today is the fastest browser, but of course, the other vendors don't sleep. They will adapt and change their browsers. Okay. Now, let's go into the sample mode. And in the slide deck, when you download the slide deck, you will see that there are, I don't know, 30, 40 more slides giving you links to these resources, which I'm going to show you throughout the demos. But I will jump over them, and I'll only come back to the slide deck later on at the end of the session. Okay, for all these samples, I'm going to use Visual Studio. Let me just start the Zoom tool. I forgot about this one, I'm sorry. Let's start Zoom it, and let me just move this a bit. Okay, so what I'm doing is, I'm running this in Visual Studio. All of those samples are .html files. So there's no dynamic code running on the server side. There is one thing running on the server side, which is down here. That's just an ADO.NET data service, a WCF data service, which exposes an OData endpoint into the Northwind database. This is really just being created by clicking through the entity model wizard and by taking this entity model and wrapping it into an ADO.NET or WCF data service. Okay. That's just a read-only access to my data. Okay, I'm going to look through a number of samples with you, and we'll build upon them, and I'll show you different ways to think about HTML5 and ways which are important when you think about HTML5. So let's first look at a regular Ajax-only sample. No HTML5. This sample runs on, I think it runs on IE6 without any changes. That's old school. It's fun. It's really great that we can call something which has been invented or popularized 4 years ago. We can look at it and say that's old school. But let's see. I'm really looking forward to the time when I can call this HTML5 stuff old school. We're now doing HTML6. Change is the only constant in our business. I've seen a session by David Chappell about 12 years ago, a keynote session, and he said, you know what? When they introduced .NET, and he said to all these unmanaged code developers, he said, I know that some of you are furious because Microsoft is now changing everything you've ever learned. You have to relearn everything. And he said, you know what? If you don't like change, you're in the wrong business. Change is our constant. Okay, so we have another change here. Now, that's the first one. We're loading data from our server. I just click a button and it fills this list items. Now, if we do this in Ajax, and I'm explicitly not using Microsoft Ajax framework here, but I'm using one of those more HTML5-ish frameworks. And this would be old school Ajax.html. So how does this look like? Well, I'm using a framework called jQuery. I assume that if you are a web developer today, you've heard of jQuery. So I'm not going to go too much into jQuery. It's just one of those JavaScript libraries. There are a number more. There are different libraries like Dojo, Prototype, Scriptaculous, etc., etc. jQuery is the one I'm choosing for these samples. The reason is simply that jQuery is today very closely aligned with Microsoft. Microsoft is funding a lot of this open source development in jQuery. So I assume that whatever Microsoft comes up with in the future in terms of IDE support will be targeted more towards jQuery than any alternative framework. But that's my opinion, personal opinion. You can use whatever framework you want. The important thing here is if we click on the button, and this is not modern JavaScript, that's old school JavaScript, the way we have written it for 10 years or something. I have just an on-click on my A link. If I click on it, it calls a method. $.ajax is the jQuery method to issue an Ajax request. You pass in a URI. In my case, I just passed the URI, the automatically generated UI to my OData service. I tell it that I expect JSON, and on success, I pass in a callback. That's a callback method. I could have written this method inline here, but I really just wanted to separate this for now. This callback is called as soon as the data has been retrieved. It's called asynchronously, and I then iterate over the returned data, and I'm appending a list item for each record I've retrieved from the server. So that's code which you see quite often today in applications which write lower-level JavaScript code. That is, if you look at what Facebook does, or what all kinds of common HTML5-ish applications do today, or Web 2.0 even do today, that's more or less how they would look like. Now, that's one approach. You can do a similar thing with templating, because the fact that you have to iterate over something, and you have to mix script and non-script, and you have to generate HTML inside of your script, etc. That's something which I personally don't like very much. And together with jQuery, there's this concept of plugins to jQuery, and there are plugins, for example, for templating. And if you do the same thing with templating, let me just open this one. The only difference up here is that I've included a script reference to this template as well, templating environment as well. And then you can define your template in a script block. I'm using an obscure feature of all of today's browsers here, that I can define a script block for a language which the browser doesn't actually know. So my browser doesn't know how to interpret script.template. Actually, it would be nicer if we call it script.x my template or something. But it doesn't matter, because the browser does not know what to do with this kind of script, so the browser will ignore it. But what's happening is the script gets an ID, so I can later reference it. And that's what I'm doing here in the new showData method. I take my target. Now, my target is this unnumbered list up here. That's the UL, that's the container for all these bullet points. It has the ID target. So I'll fetch a reference to target. Dollar and selector is a jQuery operation for those who don't do web development, which give me a reference to this element. And I clear it, and then I add these items, but I can do this by just using this template mechanism. I say $template, and take this template, that's my script block, use this list of data, and put it inside of the target. Now we get some kind of separation between the real UI logic, which is in this script, in this template, and the code. I don't have to mix code. Now, it's easy if you have a simple template like this. I could write this using code, there's no problem. But if my template gets more complex, using a template is actually a good thing. I personally don't write code without templates anymore. If I can do it with a template, I'd rather do it in this way. Okay, but that's still old school Ajax. Now, let me go back to my sample. Oh, it's still running, okay. And the problem with this old school Ajax is, if my server is not reachable, or if I'm running over a slow network connection, my user will not get data. If I kill my SQL server on my machine, my user is not going to see any data. So I've got a second way of doing this. I'm going to show you how to do this in just a second. It looks the exactly same way. So I can run load data, and that's Ajax with templating. That's not the one I wanted. I wanted to have the local storage. And I can load data from my server, and I have a second option to load data from a local store. And let me just close this browser again. I stop my SQL server now. I'll reopen my browser, and I load it from local store, and I still get the data. There's no round trip to the server in here. And this is persistent data. It's stored for longer than one session. If I would try to do the same thing by loading it from the server, I will not get any data, of course, because there's no SQL server. That's now the first HTML5 feature which you're going to see in this session. The rest was just to set up this example. Now, local storage is not extremely complicated. The only thing I'm doing is I replace this callback, the callback which used to call show data, and I'll change the callback so that it does call show data, but then I'll take the data which I've retrieved from the server, which is a deserialized JSON object. I need to stringify it again, to serialize this into one string, and then I use this local storage feature, which IE9 and all the other current browsers provide you with, to store data. That's just a persistent key value store. You can put whatever you want into this. And if you put complex data types, you have to put them into a JSON string and deserialize them from a JSON string. So when I call load from local, I just go to my local store again, call get item on it, and call JSON.parse JSON data. Now, does this work on IE6? Well, no. IE7? No. IE8? Hardly. This works on HTML5 browsers. So your application now has to somehow make a decision whether or not to use this feature or to ignore this feature. Because, again, the idea is progressive enhancement. You create an application so that it runs on a downstream browser, but you know, if your user has an upstream browser, has an HTML5 browser, they'll just get the data quicker because they'll get a previous view of the data. Just assume that you're running your, I don't know, Facebook list of friends. There is no reason why this couldn't be stored offline, and whenever you change it, whenever you add a new friend, you'll add it to your offline store. You might sync them up in the background, and even if your user is on a low bandwidth connection, a mobile connection, they can interact with the data in a very, very fast way. Okay. So now we need to have some kind of feature detection. The one approach to detect features is, well, I'm not even going to show you this. That's the one you should never use. You should never detect a browser. That's important. If you take only 3 things home from today, this would be the first one. Don't detect the browser. We never check the user agent string, whether it's IE or something like this. We detect features, not browsers. Browsers change all the time. I don't know, Firefox or Chrome, they release in very, very quick release cycles, or Safari as well. And you know, from one version to another, you might have a feature, and actually, and this has happened in the past, a feature might be removed again because it's not stable enough. As I said, that's a moving world, so you simply detect the feature and use it if it's there, and fall back if it's not there. So how do you detect features? Well, usually, there is an easy way to detect features, but of course there are cross-browser differences or cross-feature detection differences. So let me go into this sample which does feature detection. Let me just start this one again. We have low-level feature detection, which is called local storage feature detection. I was just looking for the name for this in my sample. Okay. To do a feature detection, what you can do is you simply check for the existence of the local storage object. If window.local storage does not exist, well, then you assume that you're running on a down-level browser. So that's the way you detect features, never browsers. You really look at your browser and say, well, do you have this method or do you have this property? If you have it, yep, then I'll use it. If you don't have it, then I won't use it. The reason you detect features and never browsers is because of a concept called polyfills. Oh, let me just increase the font size here. Polyfills or shims. Now, a polyfill or a shim is a component, is some JavaScript library which you can load into an existing browser, which provides you features which provide the same API as your HTML5 browser, but they do it in a different way. So maybe they provide local storage using some kind of, I don't know, a hidden Silverlight control or something like this. They provide some API level abstraction, but use a different implementation. A polyfill is something which you need if you want to be compatible with a downstream browser and if you also want to be feature compatible. Because there are a number of ways a downstream browser can store data. There are Flash-based ways, there are Silverlight-based ways, and you could easily provide a JavaScript API which simply provides this window.local storage object in your browser, which normally would not have this object. Okay, so that's one of the reasons why you cannot check for browsers, because you really don't know. Your application might actually contain a polyfill which supports additional properties. Okay, and then it's the same thing. Now, checking for all these is a bit tedious. Now, it's easy for local storage. It's a quite simple check, but there are HTML5 features for which the check is a bit more complex. And there is another library for this, a library which does feature detection, and this library is called Modernizer. And if you do any HTML5 development today, you will quite likely come in touch with Modernizer pretty quickly. Modernizer allows you feature-by-feature detection of HTML5 features. Now, if you go to the Modernizer website, modernizer.com, let's see if I'm online or not. I should be online, but I'm not really betting on this. Well, I don't need to be online anyway. I just wanted to show you how Modernizer does things on their website, because even their homepage lists a number of features your browser supports. But we can run the same thing or a similar thing locally. And let me just go back to my start page. We do feature detection with Modernizer. And there are two ways to do feature detection with Modernizer. The first one is script-based detection. I'm going to show you the code in a second, in which you can just use JavaScript to find out if your browser has a feature or not. And that's always one line of code. Modernizer provides you one particular property for each feature, which you can address and which is documented. Or Modernizer also provides you style-based detection, in which case Modernizer changes the HTML tag at the top of the page and adds styles for every feature your browser has. They add a class to the top-level HTML element for every feature the browser has and for every feature the browser doesn't have. So for example, let me start up the IE9 developer tools and zoom into this. What you see here are the different features. These are classes which are added by Modernizer. So Modernizer added the class JS because my browser supports JavaScript. But my browser doesn't support Flexbox, so they added a no Flexbox. But it does support Canvas, etc., etc. And so you get a CSS class for every single feature, for every HTML5 feature your browser supports. And then you can do things like these and just hide information which is not relevant if you don't support a certain feature. So you just hide it style-based. You just do a display.none, a display column none, for example, for this particular style. Okay, the feature detection code is extremely simple. I just, well, that's again jQuery code. I have a number of LIs up here, which have a span for each feature, and I want to change the span to yes and no, the inner text of the span. So I look for each of those spans, and I just look at the different properties in Modernizer. So I just check, do you have local storage, session storage, hash change, index.db, etc. And I write yes or no. So that's script-based detection. And if you go into Modernizer dot, you'll see that it has a number of things it can detect so that your application can take advantage of this one. Why is this important? Again, progressive enhancement. You want to fall back to a usable application, but you just don't provide these features, or you provide an alternative implementation using jQuery instead of a native browser feature. Let's say there's something which is called a CSS transition, where you can move elements on CSS base, on a style base. So you don't have to animate the left property, for example, but you can just go there and say, okay, move from this style with left 0px to left 300px, and you can just say, okay, animate this in 0.5 seconds. And your browser does this hardware accelerated. Now, if you don't have this feature, then you can fall back to jQuery. That's again, it's one line of jQuery code which does the same thing, but it doesn't run hardware accelerated. So if you have a phone, for example, the first one will look like a native transition on an iPhone, and the second one, which would be the fallback solution, would, well, maybe look as a tiny bit choppier or something like this. Okay, but that's always progressive enhancement. That's a very important keyword here, because otherwise you would not be able to write an HTML5 application today, because quite likely you will have to support one or another downstream browser. Okay. Now, one thing which was interesting for me, if you have written JavaScript in the past, you might have ended up using Firefox as your browser and Firebug as the debugging tool for JavaScript. Everybody who has written JavaScript, I think, has seen Firebug and has spent way too much time with it. It was a fantastic debugging tool. Today, if you look at the integration between Visual Studio and HTML and IE9, the debugging feature is fantastic. So I just go there, and you have regular debugging. It's a lot faster than doing JavaScript debugging in Firebug. If you do step-by-step debugging, it's a lot faster. Firebug used to take a lot of time to evaluate next expressions and so. So if you have not looked at Visual Studio-based JavaScript debugging, that's something I totally recommend. And now that IE9 supports HTML5, that's a perfect environment to test and debug your HTML5 apps. In the past, this wasn't possible because IE8 didn't support HTML5, so you had to run it somewhere else. And Visual Studio does not debug using Firefox as a browser, of course. Okay. So if you do the same thing, let's say in a virtual environment in IE6, that's now Windows XP virtualized running IE6. We're doing the same feature detection, and of course, well, there's no feature here, and down here you can see that all of them are gray as well, so no feature has been detected. And that's how you could do progressive enhancement, how you could do fallbacks, etc. Okay, so let me get back to my samples. So that's one of those things, one of the first levels of abstraction. And if you take, as I said, I'll give you 3 different things from this session. The first one is you never detect a browser, you always detect features. The second one is in HTML5, you have to pick your abstraction. You can work on a very low level, like I did here, and you can directly interact with your HTML5 environment, with your data, etc., or you can use abstractions. And that's where the power comes from. HTML5 plus JavaScript plus CSS3 at a low level is extremely complicated. There are still today cross-browser differences. They are smaller than they used to be in the past, but it's still complicated. But there are a number of frameworks which allow you to move to a higher level of abstraction, and you can pick and choose. So Microsoft has, for example, released one which they call Data.js, which abstracts OData access. So, well, at the beginning it looks the same, but I can now load more data. No, that's only on the second sample, I'm sorry. So this encapsulates OData. It's a script that's a fairly new thing. It's called Data.js, it's from Microsoft, it's released on Codeplex, and it does read and write access to an OData endpoint. And that's quite nice. Now, the code looks at the beginning very similar, so let me just go to OData with Data.js. And it's just a JavaScript library. That's always the important thing. Everything is just JavaScript. I still use a template here, but instead of running the Ajax call, I call OData.read, pass in my OData URL and my callback method, and then of course the code looks very similar, but now I'm not formulating this as an Ajax query. Well, on the first step, that's not too interesting, but the thing is, Data.js provides you with a local cache. It can abstract local storage away from you, so you don't have to deal with local storage. In the next sample, when I go back and go to OData and caching, I can load data from a cache. OData provides this transparently for me. I can page through the cache. That's what I've implemented here. But the important thing is there's not a single round trip for every item. Instead, it batches round trips. You can configure the cache. It goes to the server for 50 items, and then it lets me page through them and only goes to the server for the next 50 items. And in code, this looks like the following. Let me just show you this. That's in OData and caching. Instead of directly going to this URI, what I do is I create a cache. Using Data.js.createDataCache, I give it a name, which is used for local storage as well, and I pass in the source. And when I want to read data, I just call cache.readRange. I say, you know what, I want to read from current index to 10, and then call the callback method showData. And that's a callback method here because we don't know at the beginning, we don't know if this cache is going to be, or if this element answers from the local cache or from a server, or needs to run a server-side request. And if it runs a server-side request, of course, it has to be asynchronous. There's no way in JavaScript to execute a synchronous request to a server. And if I would kill my SQL server again, this application would still continue to run. You would still have the elements stored in a local cache. But now you don't have to even take this into account. Again, you pick your abstraction. If you want this abstraction, if you want automatic cache management, go for it. That's not the only library which does this. There are more libraries which support automatic cache management. And you pick one of them, and you can then use those to encapsulate the interactions with your server. Okay. And again, this abstraction, for example, falls back on, supports IE6. So you could run this in a fallback mode in IE6 without changing any code. It automatically takes this into account, whether or not it can use offline storage, persistent storage, or not. Okay. Now, what happens if you want to have a different kind of abstraction? Like you don't want to use template-based display, but you want to use a grid control like you're used to. And yep, there are grid controls. There are abstractions like these. It's a paging grid control. It allows sorting. It allows paging. It gives you all the regular features you have in a grid. And it's an interactive grid. So if you want to have a grid like this, you also don't have to write them yourselves. This example uses JQ grid. That's a very configurable grid. It uses paging. It uses this offline cache. It would also work offline. And I don't need to take any of this into account. I did not create an HTML table here. Instead, I picked a different level of abstraction, which looks very different from regular HTML, because this grid is defined programmatically. I define my grid in this method, and this just says, I need a grid, and I have these column names. These are the headers. You define a model. It's a model-based grid. You say, these are the elements. You can define width for each of the columns, data types, etc. You then say, okay, I want to have a pager. The pager should be in this DOM element. And you define a mapping from your JSON format into the grid. And to provide data, you just provide a callback method, for example. So in the callback method, I again call cache.readRange to read a certain page of data, the page of data which has been requested by the grid. So that's a grid which gives you virtualization like a desktop grid. I can run this grid on a database with 10 million rows, and it would just request the rows it really needs from my database. And that's the interesting thing. You can implement server-side sorting or client-side sorting. It's extremely powerful. That's JQ grid, if you're interested in this. Now, grids are an important thing here. And that's always the problem in general when you look at levels of abstractions. That's something you have to be very, very careful about. If you pick a level of abstraction, what does this mean? Well, usually it means you pick, let's say, a plugin to jQuery or an extension to some other framework. And some of those plugins are the official jQuery plugins, and most of those plugins are third-party plugins, something a developer has written. And if you pick an API or a plugin like these, you have to be able to maintain the code. Because it could well be that the other developer has solved his or her problem, and they have never intended to maintain this plugin. For JQ Grid, the situation is quite interesting. JQ Grid is not the official jQuery grid, but jQuery has quite recently, the group behind jQuery, has decided to look at all the available grids and take features from them and create one official jQuery grid. So there will be an official jQuery grid control in the future. Microsoft is contributing money and development resources to this grid, for example. But right now, you could take JQ grid. It allows you also editable grids, etc., etc. It does what a regular grid control does. And you don't have to write HTML for this. And there are other frameworks. Like, if you're interested in this, there is a framework called Next.js. It's a commercial framework. I'm not saying that this is good or bad, right? It's just a different level of abstraction. It's a commercial framework which allows you to create user interfaces in a UI designer. You have layout components like you do in Silverlight, for example. You can define certain layouts, boundaries, etc. And you define your user interface not in HTML, but you define it in JavaScript. You define it in code. And then Next.js is used to render this into HTML. So even if you say that, I don't want to deal with the HTML, with CSS, etc., you can still create applications today just by using a different level of abstraction. And if you use Next, you would hardly ever see any DOM-specific manipulation code like I've done here. You would always work in your JavaScript world. Now, of course, it's a commercial framework, which is good because this means quite likely it's going to be around in 2 or 5 years from now. But at the end of the day, that's a risk assessment you have to make. If you create an application based not on HTML, but on purely a proprietary JavaScript way of doing it, then this can be extremely powerful, but of course we don't know whether or not this is going to be around in a few years from now. Okay. So these were the first things. This was just talking about local data. But that's very important because it's the first thing which I think explains a bit about what HTML5 is about. It's about localizing your application. It's about taking your application from this pure web client-server interaction model, moving it into a server-based, into a client-based model, into a model where you interact with your local data. The next thing which goes into this is the Canvas API. a canvas gives you a local drawing surface. Now, what is a local drawing surface? Well, in this case, I've created a canvas here. That's the canvas. And I'm going to show you in a second how this is done. And I just want to draw onto it. So you can draw. This is just drawing random rectangles. I just need to get away from this tooltip. And I'm just drawing random rectangles over this canvas. You can clear it. You can interact with the canvas. OK. Now, a canvas that's a pure HTML5 feature. Normally, if you're, let's say, a game developer, you could directly interact with the canvas. If you're a business developer, you could directly interact with the canvas, say, to create a chart or something. However, in a few steps, I'm going to show you something different, a different way to interact with the canvas, because there are a library for this. There are a library for gaming, there are for regular 2D gaming, there are libraries for all kinds of charting, etc., which are based on canvas. So nothing here is server-generated. When I click on, let me just decrease this a bit. When I click on draw random rectangle, that's done on my client. There's no round trip at all. The drawing is purely done on the client. If you can animate them. We can animate those as well. So because it's just JavaScript, it's just a JavaScript animation. I can run a few hundred. Now I'm at 1,000 rectangles now. This animation is really moving 1,000 rectangles around, and we are still getting 60 frames per second. 60 frames per second, by the way, is, if you do animation, is what you want to achieve. If you know JavaScript, just a quick aside, if you know JavaScript, you know that there is a window set timeout method or a set interval, which allows you to specify a piece of code and an interval in milliseconds, how often this code is ran. So you could, if you do animations, you have to always draw one full frame, of course. Now you could go ahead and you could set this interval to, I don't know, 10 milliseconds, or you could set it to 1, etc. But you don't want to do this. You actually want to set it to 17 if you do animations, because 17 gives you the closest approximation of 60 frames per second. And you don't want to do more than 60 frames per second, because by being faster, your animation would become choppy, because you would miss the frame refreshes. You'd move your animation twice. If you do 10 millisecond delay here, you'd move your piece 2 pixels, for example, and then you get a redraw. Then you'd move it 1 pixel, and then the next redraw would happen, because the redraw is not in sync. If you set this to 17, actually it would be 16.7, but 17 is the better choice. If you set this to, for performance reasons, if you set it to 17, you get the smoothest 60 frames per second animation. And most of today's LCDs run at 60 frames per second. That's why this animation is very, very smooth. I hope it is smooth on the beamer. Yeah, it is smooth on the projector as well. Okay. Now, well, let's look at the code. Let's look at code first for the easy one, canvas drawing. Now, to draw on a canvas, what is a canvas? A canvas is just an HTML tag. Again, there is a polyfill or shim for this, which is called IE canvas. If you want to look into this, there is IE canvas. That's a canvas element for down-level Internet Explorer browsers, which simulates canvas capabilities in older browsers. It doesn't support everything, of course, but it supports some, or this, let's say, maybe the most important canvas features. And to do something with a canvas, what you do is, of course, you first have to look your element up in the DOM. That's jQuery for look up my canvas in the DOM. jQuery always internally has a reference, has a list of items which match this selector. So I'm taking item 0 out of this list. And then I'm checking, well, does this canvas have a getContext method? That's a feature check. I'm checking whether or not my canvas has whether or not my browser has a feature. And I need to have a getContext feature, a method in this case. And if I have getContext, then basically, if you don't know JavaScript, you can run an if clause or an if statement on anything, and it will return true if this thing is defined and if it's not 0 and not null. That's the check here. And so it checks, is this method defined in my case? And defined in JavaScript means, does this object have a field called getContext. This field could be a regular field or a method. Okay, but basically I'm just asking this object if it has this capability. And if yes, I execute this and I call getContext2D because I need to have a 2D canvas. If I get one, I just interact with it. There are about 40, 45 methods on a canvas which allows you to draw things. Canvas it's really a canvas. It's not an intelligent library which does vector-based drawing like SVG would do, but it's a canvas. It's bitmap-based, and you just modify the bitmap. It's like Microsoft Paint, and you paint things on it. There is no undo in Canvas, etc. So if you want to animate things, you basically have to redraw your whole canvas, or at least the parts which have changed, on every frame. And that's what I'm doing in Canvas animation. There I have an array which holds a number of rectangles which are currently being animated. And here I do this set interval. So I say, call the method drawFrame every 17 milliseconds. And I'll output the frames per second counter every few frames. But in general, what I'm doing here is I iterate over this array of rectangles. First, I clear the canvas, and then I just calculate the new position for each rectangle, and at the end, I draw the rectangle at this new position. So it's a very simple API. Now, what happens if you need higher level capabilities? And that's again, libraries come in. Now, if you need drawing, let's say you need charting in your application. And yes, of course, you could create a chart or a diagram directly onto a canvas, no question about this. But there are so many different drawing tools right now, or drawing libraries in the jQuery universe, that I think this might be a waste of your time. So you could do canvas-based charting. And I'm going to show you the code in a second. But now, you just take your series of data and you define your axis and you just throw your series of data at a charting control. And again, this is done client-side. That's not a server-side chart. In fact, you can go a step further, and this chart is now just started with a different property. It's now zoomable. So you can select something, you can zoom onto it. Now, of course, in this chart, it doesn't really make sense to zoom, but it's just to show you that this works. Pure JavaScript-based. There's no Node Flash, no Silverlight behind this. That's just one it's just one library. Could I create something like this? Well, yes, but it would take a lot of time to do this because, all this, the tracking, the selection window, all these things are implemented in this JavaScript library jQplot for plotting values. That's not a native feature of Canvas. Canvas has no object detection features or anything like this, but the library does. Again, you pick your level of abstraction. And if you look at the Canvas charting, for example, let me just break this a bit. That's it. I create a div up here into which the charting component will draw its canvas. And then I go to this. I'll empty the div if there has a chart being drawn already. And then I call jQplot. And I tell it, use this div and use this data. And the rest is now the default configuration. Of course, you can configure exactly how the axis should look like, etc., etc. It's powerful. It's extremely powerful. But in the easiest case, it's just, that's your canvas or that's your div, put a canvas and draw this chart. Done. Progressive enhancement in this case means if you run this on Internet Explorer 6 or even 7 or 8 on a non-Canvas compatible browser, you'd have to provide some kind of way to do a server-side round trip. But if you run this on a HTML5 browser, you can do this purely client-side. That's always the thing. It's always progressive enhancement. To do the same thing with zooming, let's say there should be the zooming one. The zoomable chart is quite similar. You just pass in another configuration option, an option which defines how the cursor interacts. You just pass this to this library. That's not an HTML5 feature. It's really a feature of this library. Another charting component would look totally different. Okay. But the important thing is, again, you pick your level of abstraction. Now, let's go on. The These were two features which showed the localization aspect of, or the becoming local aspect of HTML5. Now there are different aspects. There is a semantic aspect in HTML5, which is totally different from the thing you've seen here, because it's about increasing the semantics of your markup. Now, let's look at the code first before I show you the sample. There are a few new elements in HTML5 for semantic markup. There's an element like header, and it's currently being underlined here because Visual Studio thinks that this is XHTML or HTML4, whereas in reality it's HTML5. So this is valid, even though we see the squiggly underline here. And basically what they did is they took a few of those standard components. Like in the past, we would have had div class header /div. We would have for the header. We would then have, I don't know, div class nav for the navigation. And they just took a few of those, maybe 15, 20-ish, of those standard classes which you see in every application and moved them into real tags. They say, you know what, every application has a header, or most applications, they have header. Most applications have navigation, and they moved this into a semantic markup. If you have, for example, articles, you now have an element which defines an article, and there's a header for an article, and there's a headline group, because you can have a headline 1 and a headline 2, but you know, they belong together. And now you can express this in semantic markups that these things belong together. And they are not just divs, but you know, this is a header for an article. And this is not just a div, that's an article. So by default, if you show an article like this, if you use semantic markup like this, of course, nothing happens if you don't style it. So by default, it doesn't give you styling just by saying this is an article, or this is a headline 1, this is headline 2, doesn't give you styling. But of course, you can apply a style. And this is now just a CSS style being applied to the whole thing. And that's the reason why I don't even try to do web design. It just wouldn't work out. I was happy enough to be able to position these things in CSS. If a designer gives me a nice PNG file or whatever of a site, how they want the site to look like, I can translate most of this, but I should never try to even do it myself. But it's just styling now. So we have semantic markup and we have styling, and they are independent. That's the important thing here. You really can define your navigation. This is your navigation, and then you say, okay, how do you want this to appear? Okay. And in terms of for the designer, of course, HTML5 is wonderful, right? You get features like font face. You can now embed fonts in your application. There are websites out there where you can register yourself. You can pick the fonts you want. They host the fonts for you. You don't have to take care of licensing these fonts anymore. They'll track the impressions on these fonts, because fonts on the web are usually licensed in packages depending on the number of visitors you have. And they track everything for you. You just get yourself an account there, and then you can use advanced fonts, not just the standard 10 fonts which we used to use in the web. Okay, but that's something different. Today we're talking about the development aspects. And so that's semantic markup. That's the first thing. The second thing might be more important for you as a developer, because this really gives you not much as a starting point, because you know the browsers don't take this into account, etc. It gives you more as soon as you start to interpret these things on a semantic level, as soon as you want to interact with it. But right now, they don't give you much. There is something else which does give you much, and these are the input types. And in the past, there was input type text, or input, or the different input types, the classical HTML4 input types. And HTML5 defines a few more input types. So they say, for example, there's an input type search, an input type tel for telephone number, one for URIs, one for email addresses, one for date time, etc., etc. So you can say input type date time, this is a date time. Now, what happens with the date time, for example? Well, so that's interesting. IE9 ignores them for now. So all of them look the same. That's also good. That's a fallback. In most of the HTML5 features, you have automatic fallback. If a browser doesn't support the input type date time, for example, it will fall back to input type text. Okay, now IE9 ignores all of them. There is Safari. Safari ignores most of them, apart for the search button. If you have a search, you'll get the clear element here, because you can clear this search element again. That's a nice feature you get from Safari. If you look at input type phone number, for example, where is the telephone number? Now, why would you use input type telephone number for mobile devices? Because the on-screen keyword will be changed to allow you easier data entry for this type of information. That's why these input types are so important. If you create mobile web apps, that's what you want. You want to show the user the most applicable on-screen keyword possible. And you do this using these elements. If you run code like this on Opera, Opera today is the only browser which really supports a number of them. Well, Safari actually supports the range here. You get a range, a slider. And Opera supports them even better, so you can click on date and you get a date picker, etc. So let's again go one step back, progressive enhancement. Well, Safari has a range here, but IE doesn't. Is this a bad thing? Well, you know, you don't want your user to enter value here. But there is, again, jQuery and jQuery UI, which allow you to enhance these elements. And I haven't done it for the range picker, but I've done it for the date time entry. Again, Opera would present me with a date time entry. Now, you can't design your application for Opera as a target market because it's a niche browser, to be fair. I don't know what the current market share is, but I think it will be single digit or something like this. So I wouldn't go out there and say, you know, we only support Opera and tell your users to update to Opera. Might not work out. So what could you do instead? Well, let's just go there, and I've got a link down here, apply some jQuery magic. So I'm applying some magic behind the scenes, and when I click on date time, I'll now get a date picker. That's a jQuery date picker. It's stylable, etc., etc. That's the standard jQuery UI date picker. How did I do about this? How did I go about this? Well, I'm just saying, you know, we don't need this one. Just look at the first one. I check, does my browser support the input type date? Again, using Modernizer, modernizer.input type date. If it does support this, which only Opera would return true, I'm not doing anything. But if it does not support this feature, I'll use jQuery. This is a jQuery selector. I'll take all inputs which have the type date, all inputs on the form which have a type date, and I'll turn them into a date picker. The same could be done using sliders, etc. So that's how you would go upon these things. If your browser supports it, fine, because it's usually better. It's hardware optimized. If I run this on a mobile phone, and my mobile phone has a certain implementation of, let's say, a combo box, then it would be better to use the browser's combo box. Or of a slider, then it would be better to use, I don't know, the iOS slider if I had an iOS device. Otherwise, if you don't have a native slider, you know, use jQuery slider. That's important. Okay. Then, what else can you do with HTML5? Well, there are a number of additional frameworks. There's one which is called jQuery Mobile. And I'm going to show you this in Safari, not because the features are not supported by IE. Yes, there are some features which are not supported by IE in this jQuery Mobile demo, but this doesn't really matter because jQuery Mobile is targeted for one very specific use case. And the use case is you create web applications for mobile applications. You want something which looks, of course in this case, looks like an iOS device. And your user goes there and they can interact with it. They can again interact with your data in the same way as before. You've seen there are transitions there. Oops, when I click them correctly, there would be transitions. And they look pretty nice. If you look at this on a mobile phone, they would look very nice. They use hardware-accelerated CSS transitions on these devices. And again, you can move through the application, etc., etc. Now, do I have to write Objective-C for this? Not at all. That's the interesting thing. I've tried it once. I've looked at so as some background to this, as you've seen on this photograph before, I do some, not a lot. I do some mobile development. So I do own way too many devices. I have a 5-year-old daughter, and she likes to play Angry Birds. So she usually comes to me and says, can I have your phone to play Angry Birds? I was like, you know, nah, it's my phone. But then I have all these mobile phones. I have 10 mobile phones sitting on my desk. So she comes into my office and she says like, Dad, can I have your phone to play games? I was like, no, it's a phone for working. I need this for development. And she said, yeah, but you can't phone with them at the same time anyway. And she's right. I can't use them. But again, you need to test on these devices. So I did some Objective-C development, and because I really wanted to look into this, and I decided, there are things which you just don't have to do. It's fine. I love, the feature set is big, and the history of this environment is big, but it was just not for me. I know some friends of mine who do fantastic Objective-C development, but I couldn't. And I decided that I don't want to go there because, I'm focusing on the Microsoft space. Now, there are new updates. We don't want to install them right now. This is just JavaScript. And if you look at the mobile app, that's interesting. The way a mobile app can be designed, you don't have to do it this way, is to create a single-page application. That's a term you'll see quite often used in web. Single-page applications, because actually, even though you see 3 pages, it's just a single page in HTML. And there are attributes like on the divs, which customize the way jQuery mobile, which I've included here, interacts with the page. So it just says, this div is a page, and this div is a header, and the header says mobile web. And this div is the content for this page. And it has a list view, etc., etc. So you define your app in HTML5, and you can use local storage, etc., etc., and it looks and feels like an application. The next thing is, there is a framework called PhoneGap. And this is as close as I can get to ever being thrown off a stage at a Microsoft event. PhoneGap currently doesn't support Windows Phone 7, and I personally don't know if they are going to support it. I think that they will support Windows Phone 7 as soon as they get an HTML5 browser. The guys behind PhoneGap, they don't have, they used to support Windows Mobile 6.5. But what this thing does is it takes an HTML5 application, wraps it, creates a native wrapper around the application, and allows you to build this into a native package so that it can be deployed to the native app store. So I could take this application, and I could package this inside of PhoneGap, and I can deploy it to the iOS App Store, and it would run as a local application. I could do the same thing for BlackBerry, for Symbian even, for Windows Mobile 6.5, for Android, for BlackBerry, for all of them, for WebOS. And PhoneGap it's an open source tool. It's free, it comes with full source code. If you create mobile applications today, you should really look at PhoneGap. I'm not telling you that this is the best choice for all kinds of applications. But if you want to target multiple devices, including quite likely Windows Phone 7 at the end of the year, when they get an HTML5 browser, then you get a level of abstraction here, which runs on all devices. This includes iPad devices. I've seen iPad applications. You get multi-touch support, everything in JavaScript. And you can run, basically, you can take 95% of your code base and move it from an iOS phone to a Windows Phone 7 when it's then supported later in fall, which I don't know if it is, just so that we have the same context here. But then it would be the same code base. And I think that's something which is quite compelling for me, because I can use my Microsoft ASP backend knowledge. I know exactly how to do server-side applications. I know how to do HTML. I know how to do JavaScript. And I can package this up and move it onto a phone. And it looks quite nicely for most. Well, it's not perfect, right? It's an emulation. If you deploy this on a different phone, you can select a different theme because you don't want to run an iOS theme on an Android device. Most people who have decided for an Android device have done explicitly so because they did not want to have the application look like an iPhone. Same for Windows Phone 7, so you can style it differently, etc. But the important thing here is that it looks and feels natively. It supports multi-touch, etc., etc. Has a very nice API for this. Okay. And now, well, we've seen this. So let me just jump over a few of those. And these are just the reference slides I've mentioned before. Just slides which you can use when you download this to get all the links to all these resources. Okay, so just to recap the last 70 minutes. What I'd like to show you is a number of key takeaway points for HTML5 and JavaScript from a developer's point of view. First one, and I've mentioned this, I don't know, maybe 10 times. I'm feeling like in the movie Spider-Man, with great power comes great responsibility. He says this, I don't know, 10 times in the movie. I've said 10 times or more that you have to detect features, not browsers, because it's so important. You have to pick your level of abstraction. You don't have to manipulate a canvas on a pixel-by-pixel basis if all you want to do is write a game, because there are engines for this. You just have to use your favorite internet search engine to look for those. There are games engine, there are, of course, charting, as you've seen, etc. There are frameworks for you, for all kinds of things. I would never go out there and create an HTML5 application from scratch. The first thing I install is jQuery, or I download is jQuery, jQuery UI. This is my kind of framework. But there are others. There is a framework called Dojo. There is a framework called Prototype, or XJS, which provides this different view of the world. Look at these frameworks, compare them, find out how they work. The next thing is, and it's not on the slide, is learn advanced JavaScript. Because the way, if you don't know what a closure does in JavaScript, then you need to forget everything you know about JavaScript and start from scratch. There are concepts which have evolved over the last 10 years, and today we have a pretty nice understanding of how maintainable, component-oriented, object-based JavaScript can be written or should be written. This book, the book I've shown you, JavaScript, The Good Parts, is a very good start in this direction. The technological platform I've shown you today involved mostly around the issue of getting things local storage, local drawing. You do, on one end, you have semantic parts, like the semantic markups for articles, etc., like the input types, which will help you on the phone on the other side. So these are the two main parts, if you look at it from a developer's point of view. You will then have, of course, again, you pick your level of abstraction, not just in the big term of the big framework, but also in small things like using data.js versus doing native Ajax interactions. Both of them have advantages. You need to look at both to make a comparison. For things like plotting or grids, it's easier to just say, you know what, I don't want to write my own grid control. That's massive. I don't want to write my own canvas-based charting. That's really big. So I would always look into these. In fact, if a customer would ask me to create a charting library for them, and if they would pay me for this, I would refuse, because there are 10 charting libraries out there. There's no big point in doing this. Okay, there are things which we haven't seen too much. There is CSS3, which gives you CSS-based animations which are declarative, which can be hardware accelerated, and IE9 does a fantastic job in hardware acceleration for CSS, or for general, not just for CSS, but in general for animations. And there are things which are coming in the future. There are concepts, and they are changing all the time. There are some implementations, and then they break again. So the last two elements here, they are pretty moving. These are web workers and web sockets. Web workers give you some kind of multi-threaded way into JavaScript, and web sockets give you bidirectional communication pipe with the server. So a client and a server can exchange data, and both can initiate this exchange. If you want to have web sites which are currently updated using a Comet-style technology, then you can in the future, and this is a few years out, you will be able to use WebSockets for this. Then we've talked about polyfills and shims. I have not shown too much of those, but if you go into HTML5 development, look for these terms in your favorite search engine and to find out, do you see how I try to avoid using Google for this? So just you should Google for polyfills and shims. I'm trying really hard. Use your favorite search engine to look for this. Now, what else do you need? You will need resource combinators, because you will split your application into multiple JavaScript files, but it's important that you only send one JavaScript file to your client. Every request is going to take a while. You have not just bandwidth, but latency constraints. There is a component called compress for combine resources on Codeplex, which you can download for this. You will have to do minification and compression. Your JavaScript will be automatically compressed. Method names will be changed to single letter method names, etc., etc. And this can be done on the fly. And then at the end, there are packages for mobile OSs like PhoneGap or others, or you can just take the idea of creating a small wrapper on each native platform and filling it with JavaScript HTML-based code so that you can run inside of the environment in which you want to run. Okay, and with this, I'd like to thank you for being here. I hope that it was interesting for you, that I could give you this nice little overview from a technical side of what the HTML5 world might bring you in the future. And if you've liked this session, then maybe I'll see you again later today when I'll talk about tasks and threading, the TPL library in .NET 4, which is a totally different topic, but which is quite important as well. Thank you very much.